Hello everyone, my name is Manohar. I'm a data science trainer and consultant. Today in this webinar we are going to discuss about the computer vision. Let me tell you agenda for this discussion. In this discussion we are going to discuss about a brief introduction to computer vision. This computer vision dealing with images and videos. So we discuss what is image. Later, we discuss what is digital image processing. After that, we discuss how human can read the image as well as how computer can read the image and the difference between those. Creating one image is very hard. We discuss why it is hard to create an image. After that, we discuss various applications of computer vision. And in the end, we discuss the advantages and disadvantages of computer vision. Firstly, let us discuss about what is computer vision. Computer vision is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. From the perspective of engineering, it seeks to automate tasks that the human visualization system can do. Computer vision is concerned with the automatic extraction, analysis, and understanding of useful information from a single image or a sequence of images. It involves the development of a theoretical and algorithmic basis to achieve automatic visual understanding. As a scientific systems, computer vision is concerned with the theory behind artificial intelligence systems that extract information from images. The image data can take many forms, such as video sequences, views from multiple cameras, or multi-dimensional data from a medical cancer. As a technological discipline, computer vision seeks to apply its theories and models for the construction of computer vision. Let us discuss about what is an image. An image is the representation of external form or internal form or a cut section of a person or a thing in art. When you look at the left image and right image, you see people, objects, and buildings. It brings up memories of past experiences, similar situation you have encountered. The crowd is facing the same direction and holding up phones, which tell you that this is some kind of event. The person standing near the camera is wearing a t-shirt that hints at what the event might be. But to a computer, this image, like all images in an array of pixels, numerical values that represented shades of red, green, and blue. One of the challenge computer scientists have grappled with the since of 1950 have been to create machines that can make sense of photos and videos like humans do. Let us discuss about how visualization system works with a computer vision system. First, let me tell you how do humans can see. Human vision revolves around a light and does not involve repetitions or patterns. In other words, we do not need to learn how to see. It is a biologically ingredient in us. Human vision consists of multiple steps. First, light bounces off the image in front of you and enters your eyes through the cornea. The cornea then directs the light to your pupils and iris, which work together to control the amount of light entering the eyes. After light passes through the cornea, it enters the retina. The retina has a special sensors called cones and rods, which are involved in seeing colors. When the cones and the rods have been exposed to light, they translate the visual information into electrical information. The optic nerve sends this information to your brain. The brain's visualization cortex interrupts the electrical form of the image, allowing you to form a visual map in your mind. Now let me tell you how computers can read an image. Computers see the world through pixels. The smallest element of image is called pixel or a picture element. It's basically a dot in a picture. An image contains a multiple pixels arranged in rows and columns. You will often see the number of rows and columns expressed as the image resolution. For example, an Ultra HD TV has the resolution of 3840 by 2160, meaning that it's 3840 pixels wide and 2160 pixel high. But a computer does not understand the pixels as a data of colors, it only understands the numbers. To convert colors to numbers, the computer uses various colors models. In color images, pixels are often represented in the RGB color models. RGB stands for red, green, blue. Each pixel is a mix of those three colors. RGB is great at modeling the colors humans pursue by combining various amounts of red, green, and blue. Since our computer only can understand the numbers, every pixel is represented by three numbers corresponding to the amounts of red, green, blue present in the pixel. In grayscale, the grayscale image is called a black and white image. Each pixel is a single number representing the amount of light or intensity it carries. In many applications, the range of intensities is from 0, that is black, to 255. That color indicates the white color. Everything between 0 to 255 is various shades of gray. Now let me tell you what is digital image processing. In the image you can observe two images. In the first image you can observe the IC, but in the second image you can observe there is no IC. In the second image there is no IC. Why so? It processes the first image by changing some pixel values with help of digital image processing. Digital image processing deals with the manipulation of digital images through a digital computer. It is a subfield of signals and systems but focuses on particularly on images. Digital image processing focuses on developing a computer systems that is able to perform processing on an image. The input of that system is a digital image and the system processes that image using efficient algorithms and gives an image as an output. In computer science, digital image processing is the use of the digital computer to process digital image processing through an algorithm. As a subcategory or a field of digital signal processing, digital image processing has many advantages over analog image processing. It allows a much wide range of algorithms to be applied to the input data and can avoid problems such as the dimensions, perhaps more. Digital image processing may be modeled in the form of multidimensional systems. The generation and the development of digital image processing are mainly affected by three factors: the development of computers, second, the development of mathematics, especially the creation and improvement of discrete mathematics theory. The third one is the demand for a wide range of applications in the environment, agriculture, military, industry, and medical science has increased. Smartphones have cameras, right? And taking a photo or a video and sharing it has been never been easier, resulting in an incredible growth of modern social networks like Instagram. YouTube might be the second largest search engine, and hundreds or hours of a video are uploaded every minute and billions of videos are watched every day. The most difficult thing to understand are the ones that are fundamentals. We live in a visual world. We see things and instantly understand what they are and what we can do with them. We can not only identify them but also understand their particular attributes and the classify them belong in. Every pixel in an image contains a color. Every color can be represented by three numbers ranging from 0 to 255. I can write these numbers in the form of n1, n2, n3, which represents a red, green, and blue values respectively. For example, 255, 0, 0 represents a color red, and 0, 255, 255, 0 represents green, and 0, 0, 255 represents a blue color. Using different values for these numbers, you can write whatever the color you want. So if every pixel contains a color, that means every pixel is described by three numbers. So if you have an image that is 100 by 100 pixels, that means that this image is represented by 100 rows and 100 columns and three colors like red, green, blue, and totally 30,000 numbers. Imagine being given 30,000 numbers ranging from 0 to 255 and being told to figure out whether these numbers represent an image of a robot. Now you have an idea about why this is such a difficult task, and you can observe image in the middle. In that image there are different colors at different positions. Now let me tell you a few applications of computer vision. Computer vision is used in object detection, security, optical character recognition, face recognition and thumb impression, target detection, sports, traffic signals, self-driving cars, interactive games, inspection, medicals. Let me tell you each of its application one by one. Firstly, let me explain the object detection. Object recognition is a general term to describe a collection of related computer vision tasks that involve identifying objects in a digital photographs. There are few computer vision tasks that are there to recognize an object. There are image classification and localization. Probably one of the most well-known tasks in a computer vision is image classification. It allows for those classification of the image as belonging to one of set of predefined categories. Image classification involves predicting the class of one object in an image. Object localization refers to identify the location of one or more objects in an image and drawing around a box around them content. Object detection combines these two tasks and localization and classification one or more objects in an image. Let's take a simple binary example. We want to categorize image surrounding to whether they contain a tourist attraction or not. The classifiers will be respond that the image belongs to group of that image containing the tourist attraction. This does not mean that is been necessarily recognize the Eiffel Tower, but rather than it has previously seen photos of the tower and that has been told that images contain a tourist attraction and target detection and tracking of the video is an important part of intelligent monitoring systems. This paper proposes an algorithm which uses the matching trajectory to recognize and realize the target tracking which based on the Gaussian mixture model. Firstly, we use background subtraction to detect the target. Secondly, the feature of the color information, position information, shape information, and modified of arithmetic are used to find a matching trajectory. At last, we get the results of target tracking. Experimental results shows the method has certain matching time based on the good detection rate in a target detection and tracking. Let us discuss about the optical character recognition. Automatic number plate recognition is a technology that uses optical recognition techniques on an image to read vehicle registration numbers to create vehicle location data. It uses existing closed circuit televisions, road rule enforcement cameras, or cameras specifically designed for the task. Automatic number plate recognition is used by police forces around the world for law enforcement purposes, including to check if the vehicle is registered or licensed. It is also used for electronic toll collection on paper, use roads and as a method of cataloging the movements of traffic, for example, by highways agencies. Automatic number plate recognition can be used to store the image captured by the cameras as well as the text from the license plate. With some configurable to store a photograph of the driver, systems commonly use infrared lighting to allow the camera to take the picture at any time of day or night. Automatic number plate recognition technology must take into account plate variations from place to place. Privacy issues has caused concerns about automatic number plate recognition, such as government tracking citizens' movements, misidentification, higher rates, and increased government spendings. Let us discuss about the face recognition and the thumb impression and the security systems. A facial recognition system is a technology capable of identifying or verifying a person's from a digital image or a video from a video source. There are multiple methods in which facial recognition systems work, but in general, they work by comparing selected facial features from given image with faces. It is also described as a biometric artificial intelligence based applications that can uniquely identify a person by analyzing patterns based on the person's facial texture and shape. While initially a form of computer application, it has seen wider uses in recent times on mobile platforms and in the form of a technology, such as robotics. It is typically used as a access control in a security systems and can be compared to other biometrics such as fingerprint. Although the accuracy of a facial recognition systems as a biometric technology is lower than fingerprint detection, it is widely adopted due to contactless and non-invasive process. Recently, it has also become popular as a commercial identification and marketing tools. Other applications include advanced human-computer interactions, video surveillance, automatic indexing of images, and video database, among others. A fingerprint is an image impression left by the friction ridges of human fingers. The recovery of partial fingerprints from a crime scene is an important method. Moisture and grease on a finger results in a fingerprints of surface such as glass or metal, right? Deliberate impressions of entire fingerprints can be obtained by a link or other substances transfer from the peaks of frictions ridges of the skin and to a smooth surface such as paper. Fingerprints records normally contain impressions from the pad on the last joint of fingers and thumbs. To fingerprint codes also typically record portions of lower joint areas of the fingers. Human fingerprints are details nearly unique, difficult to alter and durable over the life of an individual, making them suitable as a long-term markers of human identity. They may be employed by police or other authorities to identify the individuals who wish to conceal their identity. And one more thing that we count how many are getting in and how many are getting out. We can calculate like that. And in some malls, mobiles, shops, they use CC cameras to find the thieves. In their cameras, they use multi options like face recognition while getting in and counting the numbers. In sports also, this computer vision can be used for the purpose of if the player is playing the cricket in the ground, then that time the visualization will absorbed by the trainer. The trainer will get the information how the player is playing the game. After the completion of that game, they will identify the mistakes of the trainer mistakes of the player. Then trainer will train the player, then they will get good results. Just consider this image. In this image you can observe there it is a sixth boundary, it is a fourth boundary, it is a single wicket, it has a four. How the ball is dropped down, this visualization will help to train the player. And here also you can observe the tracking system. In the tracking system, they will identify the person how they are moving the position. If they are moving in a wrong side or right side, the trainer will identify the player mistakes. After completion of that game, they will tell the mistakes of the player, and again they will train the player. Next time they will get more results. Now let us discuss the cartoons. The cartoons are made with help of computer vision itself. Many are thinking that cartoons are making from various softwares, various things. They think like that, but nothing like that. Humans can perform the tasks in front of the camera. After that, they will make the image as smooth. Then that time the image will appear like this. Suppose consider here an man. This man will act in front of the camera. After that, with help of computer vision, they will make the image edges. This edges you can observe. They will make that image very smooth. Then that time it will appear to us as like a cartoon, right? Sometimes it is also uh, in a cartoons we observe the many animals like tiger, elephant, many more. That animals will be created by taking photos. That photo will be placed there, and they will perform the any task in front of the camera. After that they will make the image smooth, and they will perform like that. Let me move forward. Here the interactive games. With help of computer vision, we we perform many interactive games. The PUBG game is an interactive game. This PUBG game is developed by the computer vision itself and some programming techniques. With that programming techniques, who can make any type of game, who can develop any type of game. This computer vision is developed completely with Python and computer vision itself. So you can observe there are many buildings and the fire and a man with the guns, and we can perform any songs in PUBG. With help of that songs, we can uh, make the audience very attractive. That is also done with a computer vision. With help of computer vision, we make a background is attractive to the user, right? Let me tell you how we are using the inspection, computer vision in an inspection. This computer vision is also used in an inspection. If the bottle is has any cracks on the bottle, in the production side you can observe they will in terms of production or any medical productions, they will use these inspection methods to observe any cracks on the bottle. If any cracks are available, then that time it will throw that bottle to outside. Then that time they will manufacture that bottle. After that they will get it, and they will make better. In the right side you can observe how they use in a inspection. Here there is a camera holder. With the help of camera holder, they will use a CCD camera. That camera is a high resolution cameras. With help of that cameras, they will identify the cracks and any loose connections like that. They will identify, and after that they will rectify. They will make the production very attractive. Now let me discuss about the self-driving cars. In upcoming years, self-driving cars are perform very key role in the driving. In our real life we are observing many accidents on the roads by the humans. Humans can drink and drive. Due to that, they are getting accidents. Even though uh, who are taking care while driving, that person is also getting damaged uh, due to the drunkards. Right? That is the reason most of the people are using these self-driving cars. Still, in India, that is why this is these self-driving cars are very less. Of the outer countries, these self-driving cars are very more. Suppose in the right side you can observe there is a Mars planet. On the Mars planet, self-driving cars are playing a major role because no human can go on Mars because that conditions are not comfortable to the humans. So that is the reason that car has to be the that self, it has to be drive, and it has to be avoid the hitting of rocks and any um, up and downs. It has to be face everything, right? That is the reason self-driving cars playing a major role on Mars to find that planet is efficient efficiently work for human living or not. To check that also, self-driving cars plays a major role. Since 1950s, NASA has created a self-driving cars to send that self-driving car on Mars to search for any human human interventions and how is human can live on that here on the planet or not. They want to search for that. That is the reason self-driving car is invented in the 1950s by the NASA's. But nowadays, self-driving cars are invented by the Tesla company, SpaceX. These companies are making self-driving cars very effectively in the nowadays. Let me move to medicals. How computer vision can be used in our medicals? You can observe in the left image there is a CT scanner. In the CT scanner, when I send a person through the CT scanner, that will make an image whenever where the man get affection in the body. After that, they will that CT scanner make a photo. With that photo, the doctor will identify which location is got damaged in their part. After that, they will perform any operation on that human. He will get good health. So the computer vision is also used in the medical part also. In the medical part nowadays, it is performing very major role. Sometimes, suppose consider a doctor. Doctor has a family problems and his intentions, his tensions with the tensions, he can't identify sometimes where the damage is available. Sometimes he can't identify, right? That is the reason this computer vision is useful. It has no tensions, it has no anything. It perform very well rather than the doctor. It assists to the doctor. How the doctor told to the machine will perform like that. After that, it will identify the cracks in the mind or anywhere. It will give the X-ray part. In the right side, you can observe, right? With that X-ray, they will identify and they will give the medicine to us. After that, you you make as healthy our body. Let me tell you some advantages and disadvantages with computer vision. Do not need to have embedded devices for target detection. Just use the camera and behind that use a Python programming. That's it to identify anything. No need to use any embedded systems or anything to identify the target detection. That is the reason this is a main advantage with computer vision. And next, it is a free of cost. You don't need to pay a single rupee to download and use it. It is a free and open source in Google. You can go to the Google and just search for computer vision. Then that time that will show a software to you. You can use and you can make. You can start to work with that. You don't need to pay a single rupee for that. And next, there is no limitation like human perception. Human vision for the human vision purpose, uh, there is some range. The human can see up to 3 kilometers or 4 kilometers like that. But with help of camera, it can identify an object until a 300 kilometers far from us or 400 kilometers like that. It can identify the any ranges of images, but human can identify only 3 kilometers to 4 kilometers like that. And next, it is a faster and simple process and easily manipulation of images. Right? With help of computer vision, you can easily manipulate. In our mobile, we are easily cropping the image. We can easily modifying the image. We can easily making the image bright. We can make up the image. We can how much time it is taking to perform that in our mobiles. So it is taking very less time, right? So that is the reason computer vision is very fast and simple process and easily manipulation of images. And one disadvantage is there with computer vision, that is data processing and analyzing requires large amount of computational resource and memory. Just like using small cases of memory, you can't do anything because one video will take much of memory, right? That is the reason it has more memory space in our mobile or laptop while using this computer vision. Finally, I conclude that nowadays for security purpose, the computer vision is used like thumb impression, face detection, human counting. For our mobile, for our camera, we are getting thumb impression. In nowadays, that is the greatest security purpose, right? That is the reason it has more security purpose, and also it is useful in a medical for detecting damaged portions of body. I already told you how we are using this computer vision in a medicals, right? While doing experiment in a space or other planets, self-driving cars or self-driving vehicles are needed for detecting objects by moving from one place to another place. Uh, in other planet like Mars, Moon, at that places, self-driving cars plays a major role. To search for planet, is that planet is helpful to live in that planet or not. To search for that, self-driving cars are very important. Directly, human can't go to the other planets because they will die. With this, I would like to end this webinar. I really appreciate your precious time to spend with me. In the later slide, in the later webinars, I will come in front of you with very interesting facts and lots of images, lots of very interesting facts and information. Thank you.